Kuzangpo and welcome to all class 12 science students. In this video I'm going to explain about binding energy calculation. So basically I'm going to solve questions about how to find the mass defect and how to find the binding energy. We have here a question. We are asked to calculate the average binding energy of a helium nucleus with a mass of the given value, that is 4.001506 atomic mass unit. Given that mass of neutron is 1.008665 atomic mass unit and mass of proton it is 1.007825 atomic mass unit, and we also have the value for one universal atomic mass unit, that is 931 million electron volt. So here we have to know that we are finding the first we have to find the mass defect. So therefore the equation is given: mass defect delta M is equal to sum of the mass of nucleons, that means constituent particles of a nucleus, they are proton and neutron, then subtracted by mass of the nucleus. Here it is helium, so helium nucleus we have to subtract from mass of the helium nucleus, we have to subtract from sum of the mass of nucleons. So this is the simplified version of the equation. Mass defect, we have 2 mass of neutron and 2 mass of proton because we are dealing with helium here, and we are going to find the mass defect. We put in the values and then we get 0.031474 universal atomic mass unit. So now we are asked to find the average binding energy. Before that we have to find the binding energy. In order to find the binding energy, we have to multiply the mass defect by 931 million electron volt, because one universal atomic mass unit, it is given in the question that it is 931 million electron volt. So the binding energy we get here, it is 29.302 million electron volt. Now we have to find what the question is asking. It is average binding energy, and we have to find the average binding energy by dividing the binding energy by the mass number. Mass number here, it is the mass number of helium. So average binding energy 29.302 divided by 4 is equal to 7.32 million electron volt. So that is the solution for the question. Now let us look at another question. Here we are asked to find the Q value or energy of the following nuclear reaction. So look closely at the reaction we have here. There are 2 carbon atoms. This is the reactant because it is in the left hand side and it is undergoing certain changes. It is getting divided into neon and helium, and with some release of energy. So the following data are given. Mass of carbon is 12, and neon it is given. For helium it is also given in universal atomic mass unit. So here remember that we should always use what is given there, not anything else. So in order to solve this, we have to know the equation. Mass defect is mass of the reactant minus mass of the product. Reactant is this one and the product is at the right hand side. So in the reactant side, we can see that there are two carbon atoms. That means we have to multiply 2 with the mass of 1 carbon atom. So we have this thing, minus 19.992439 plus this is the mass of neon atom and this is mass of helium atom. So here we will get the mass defect as 0.004958. So again, what we have to do, we have to find the energy, we have to multiply the mass defect with 931 million electron volt, and we get 4.615 million electron volt.